In the previous video, this is what we talked about, adding the H minus, the hydride, to a carbonyl compound to make an alcohol. And so in this video, we are going to talk about how we add the alkyl group in the same way. So the reagent that we are using to add the alkyl group with a negative charge looks like this. You got an alkyl group attached to a magnesium attached to some sort of halogen. And this reagent is known as a Grignard reagent. And so it's a French name, and so you are thinking this, do you know what this is? This is a bunch of grass, right? And so we have a Grignard. That's what you think, Grignard reagent. Okay, not Grignard, Grignard is the appropriate French pronunciation. This reagent, as we just said in an earlier video, is a carbon nucleophile, and it can react with a carbon electrophile to form a new carbon-carbon bond. And we can build big things from little things, big molecules from little molecules, extremely powerful reagent. And so the guy that invented it, he was actually doing some work on stereochemistry in graduate school, and it wasn't working out, and he was just thinking, this is not cool, this is not getting me anywhere, and it's boring. And so he asked if there was something else he could work on, and so he was given this project, and he ended up in 1912 winning the Nobel Prize for this. And you'll find that a lot of Nobel Prizes in chemistry are for people who discovered ways to form carbon-carbon bonds, because that's so important. Okay, so how do we make this thing here? We start out with an alkyl halide, and we'll just use a simple example here. Let's use bromomethane. And we dump in a chunk of magnesium metal. And usually we have to make sure that we dry the flask out so there's no moisture at all, and so we typically flame dry the apparatus, and we typically put in magnesium and flame dry the magnesium, and we crush the magnesium up so there's fresh surfaces. It's a very sensitive reaction, and it used to be something that that was kind of a rite of passage for organic chemistry, but on a humid day it was almost impossible to make it work because water kind of kills the reaction. But so what we're doing here is we are ending up with a methyl group with a lone pair and a negative charge on it, and a magnesium ion and a bromine ion, a bromide. And so let's take a look at what's happening here. What is going on with carbon? Carbon, to begin with, had 4 bonds to it, and one of the bonds was to an electronegative atom, and now the carbon has an extra electron on it, and a negative charge, and so it has gained electrons. So if it's gained electrons, it's a reduction. And then what else is happening here? Magnesium is ending up with a +2 charge on it, and so how did it get the +2 charge? It lost electrons. And so if it's losing electrons, it's getting oxidized. And bromine was when you're assigning oxidation states, you're saying, well, in the polar bond, you assign the electrons to the more electronegative atom, and so bromine isn't changing its oxidation state here, but magnesium is getting oxidized, and the alkyl group, the carbon, is getting reduced. And so this is um, a redox reaction for making this reagent. Okay, so you can start out with any alkyl halide you want. You could start with a methyl group here, an ethyl group, an isopropyl group, a t-butyl group. You can start out with an alkene with a halogen on it. You can start out with an aromatic ring. So just about any carbon, any part of a carbon skeleton you want to add, you can start out. And as long as you have the halogen in the place where you want this negative charge to be in the end, then you just react with magnesium and form this reagent, which is known as a Grignard reagent. And so then when you take that Grignard reagent and react it with the carbonyl compound, then that is called a Grignard reaction. Okay, so let's start out with a ketone here, and let's react it with, it's two-step reaction. Step number one, you add the Grignard reagent, and let's just use the one we just made. Methyl magnesium bromide is the name of it. So the alkyl group, you list it as alkyl, and then magnesium, and then the ion here is the bromine is stated as the ion bromide. So let's write this out. Methyl magnesium bromide. And that is an example of a Grignard reagent. Now I'm using up all the space where I was going to draw my product here. So, and step number two is dumping in water and acid to add that proton on. Okay? And so when we're looking at this, then we are viewing this as a negative charge on the carbon part, and a positive charge. +2 - 1 gives you an overall +1 charge there, so the charges balance out. And if we're drawing the product of this or thinking through it, then we are forming the new bond here, and then we're adding a H+ onto there, and our final alcohol product is this, and I'm going to write our new methyl group as CH3 to distinguish it from this other methyl group, and this is the new carbon-carbon bond that has formed in this reaction. So let's do another one. Let's make cyclohexanone, and let's react it with, what do we want to do? Let's put a benzene ring on it. So benzene ring, magnesium, bromine. And so when this is drawn out, this is drawn as a covalent bond, but really we have a metal and a nonmetal, and we always think of it as ionic. So when we're looking at this, we're thinking of it as, in our head, we are thinking of it as a benzene ring with a lone pair and a negative charge on it, and then we're thinking of Mg 2+ and Br- there. So that's the way we're looking at this, but it's often drawn out as a covalent bond. So that's step number one, and step number two is adding H3O. So go ahead and draw the product of that reaction. Pause the video and draw it, and then start it up again. Okay, so we have, here's our carbon nucleophile, comes in, attacks there, and kicks the electrons up on there. So here is our carbonyl is turned into an alcohol, and then we have a bond to the chain that we have added, and the chain that we've added is just a benzene ring. And so this is our product of that reaction. And here is the new carbon-carbon bond that has formed. So we add, if it's a benzene ring, it's called phenyl. So we added phenyl magnesium bromide, and that seems to be stuck on bromide, that's all right. Phenyl magnesium bromide to our cyclohexanone, and we formed as a product which is a tertiary alcohol, which is what we expected coming from a ketone. So this is the Grignard reaction, and this is the way that we build big alcohols from smaller aldehydes and ketones and Grignard reagents. So in the next video, we're going to start learning to think backwards. If this was the alcohol we wanted to make, if this is the alcohol we wanted to make, how could we make it using a Grignard reaction forming a new carbon-carbon bond?